When you get into science classes in high school and even in college, there will be situations where you have to multiply and divide big chains of fractions and whole numbers and so forth. And there's an easy way that I like to picture what's happening here. And so let's look at an example. What if I have something like 2/3 times 3/4 divided by 5/8 times 10 divided by 6. Let's just take that as an example. What I like to think of is a shish kebab. That's something like this. That's a bunch of things like meat and vegetables, bell peppers and onions and tomatoes sometimes, or whatever. You slide them all onto a skewer. That's like a long, sharp thing, either wood or metal. And so think of your skewer like this as your fraction bar. That's just the handle. Okay, you don't have to have a handle. Okay, so the way you can construct this is you start with the first fraction or whole number, whatever it is, and I take 2/3, so I simply slide it on, and I have 2/3. If I multiply by 3/4, slide it on. Here's 3/4. Okay, divided by 5/8. Well, that's division, so you flip it over and slide it on. So you end up putting the 5 here and the 8 here. Times 10. Remember, 10 is 10 over 1, so if I treat it like a fraction, the 10 ends up in the numerator. You don't have to write the 1 down here. You can if you want, but 1 times anything doesn't really change it, so I don't even have to write the 1. So any whole number that's multiplied, you put it in the numerator. Here I'm dividing by a whole number. Again, if you think of it like a fraction, you flip it over and slide it on. The 6 is going to end up in the bottom. Okay, so any whole numbers, if I multiply, put it in the top. If I divide, put it in the bottom. Any fractions, if they're multiplied, just slide them on. And any fractions that are divided, flip them over and slide them on. So this follows all the rules of multiplying fractions and whole numbers. From here, you can do whatever canceling might come to mind. Let's see what we can do. Here's a 4 and here's an 8. If I divide out the 4, I get a 2. Here's a 3 and here's a 3. Here's a 5 and here's a 10, leaving a 2. 6, I could replace it as 2 times 3. And this 2 cancels any one of those 2's. And so what I'm left with is 2 times 2 is 4 on top and 3 on the bottom, 4/3. If you write it as a mixed number, it's 1 1/3. But I prefer just to leave it as a improper fraction is the way my preference, and when you get to algebra, that's going to be the preferred option. If you have a teacher who prefers to see it as mixed numbers, then here's the answer. Okay, that's how it works. It's just a nice little picture to keep in mind as you're assembling problems like this.